So this is your first video lesson experience, and this will become a regular thing after quiz, where since everyone finishes their quiz at different times, it kind of gives people the opportunity to get started when they're ready. So after your quiz, as you've done, you've gotten out your laptop and you listen to the video lesson. So go ahead and follow along with the notes, draw examples if you want to, pause at any time, re-listen to something if you need to. You can also ask your teacher questions. Maybe not during the quiz if a lot of people still have their quiz, but you can certainly try and the teacher will let you know if it's disruptive or if they just want you to wait a few more minutes. Okay, so our objectives today. Our objectives are to construct and justify statements about geometric figures using basic postulates. So we're learning 7 postulates today. They're right here with diagrams. You've probably already discussed these in class, but I'm going to go ahead and recall them or review them with you. So what is a postulate? A postulate or axiom, so it's also called an axiom, is a statement that is accepted as true without proof. So these are not proven, they're just accepted as true, kind of like rules. So we have our postulates today are about points, lines, and planes. So here's 2.1 postulate. Through any 2 points, there is exactly, that's a key word there, exactly one line. So here's the picture, here's 2 points, there's exactly one line. Line N is the only line that can be drawn through points P and R, or that exist between points P and R. 2.2, through any 3 non-collinear points, there is exactly one plane. So if you have 3 non-collinear points, then you have exactly one plane that you can draw that contains those 3 points. Okay, they cannot be in multiple planes at one time. One point could be, but not the whole 3 non-collinear points altogether, like the triangle that's forming. A line contains at least 2 points. So we just said up here, through any 2 points there's exactly one line, but the line, if we have a line, well, there's infinite amount of points on that line, right? We just need 2 points to name the line or for a line to exist. So there has to be at least 2 points. So of course, because as we connect, it's connecting through an infinite amount of lines through there, or infinite amount of points, sorry. So here's my diagram. It says line N contains points P, Q, and R. 2.4, a plane contains at least 3 non-collinear points. So of course, at least, can we draw more points on this plane? Of course we can. So that's where the word at least, that means greater than or equal to. If 2 points lie in a plane, then the entire line containing those points lies in the plane. So if 2 points lie in a plane, then the entire line containing those points lies in that plane. Your line can't bend and be in a different plane here. That line can only exist in one plane. Okay, and our final 2.6, if 2 lines intersect, then their intersection is exactly 1 point. So is there any way you can draw 2 lines intersecting in more than 1 point? No, not if they're straight. If 2 planes intersect, then their intersection is a line. Yeah, so 2 planes intersect, they must intersect in a line. There's no other option. Alright, so let's do some examples. Always, sometimes, never. Determine whether each statement is always, sometimes, or never true. Explain. So what I want you to do now is to pause the computer, read through, or pause your laptop, read through these 4 examples, and then try to determine if it's always, sometimes, never, and think through why you're saying that. Maybe write a sentence down explaining that. And then when you have your answers, unpause and see if you are correct. Compare them to what I say. Okay, so did you get always, sometimes, always, never? If you did, then you're probably safe to move on. If you didn't, then you can listen and try to understand why or what's wrong with whatever your answer is. So it says, number 1, if 2 coplanar lines intersect, then the point of intersection lies in the same plane as the 2 lines. So coplanar lines, so these are in the same plane, and so the point of intersection, does it have to be in the same plane every single time, some of the time, or none of the time? Well, it has to be always. Postulate 2.5, right? If we go back to postulate 2.5, it says if 2 points lie in a plane, then the entire line containing those points lies in that plane. So here that means the entire line. Well, this is in that line and this is in that line, so yes, it has to be in the same plane. Number 2, it says 4 points are non-collinear. Well, can I draw 4 points being collinear? Sure. Do 4 points have to be non-collinear? No. But could they be non-collinear? Of course. Right? This could be a plane here, and this could be in a different plane going on right here. Sorry, I had a knock on the door there. So anyway, can 4 points be non-collinear? Of course. But could they be collinear as well? Of course. So sometimes they are non-collinear, sometimes they are collinear. 2 intersecting lines determine a plane. So do 2 intersecting lines determine a plane? Always. Why? Well, these 2 lines have points that are non-collinear. So here's 3 non-collinear points. And if you look at postulate 2.2, it says through any 3 non-collinear points, there is exactly 1 plane. So through these 3 non-collinear points, there is exactly 1 plane. So yes, it's just determined a plane because of that definition right there, that postulate. And number 4, plane A and plane B intersect in exactly 1 point. Never going to happen. Why? Because of postulate 2.7, which says if 2 planes intersect, then their intersection is a line. It doesn't even give a point as an option. If 2 planes intersect, they intersect in a line. Full stop. Okay, now proof. A proof is a logical argument that uses deductive reasoning to reach a valid conclusion. The guts, or the main content of a proof, is a logical chain of statements linking the given to what is being proven. Each statement must be justified with a reason. Reasons include definitions, algebraic properties, postulates, and theorems. Well, we haven't learned a lot of theorems. We haven't learned any theorems. We haven't learned many definitions or algebraic. We haven't talked about the algebraic properties. So there's not a lot we can do with proof. So we're not jumping into proof writing just yet. No formal proof writing this unit. We're just trying to practice justifying statements. So if you make a statement, like we did up here, we said this never happens, you should be able to justify why. And you have an explanation, or you just say because of this definition, or because of this specific postulate. So you need to practice justifying statements. So down here, we have a diagram over here to the right. It says in the given diagram, line M and ray TQ are in plane A. So we're going to focus only on postulates 2.1 to 2.7 on the front of the sheet. And you're going to use one of those to justify the statement that was made. So once again, I want you to pause, try this on your own, and then when you're finished, you can come back and watch and see if you got them correct. Okay, good luck. Okay, so for number 1, did you get postulate 2.5? Number 2, postulate 2.6, and number 3, postulate 2.2. If you didn't, and you think the one that you used is correct, then just ask your teacher. Have a quick conversation. See if what you wrote was correct, or just to try to get yourself to understand what's happening there. So this one is talking about 2 points, and line M lie in the same plane. So these 2 points make up line M. And if you read postulate 2.5, it says, if 2 points lie in a plane, then the entire line containing those points lies in that plane. So these 2 points lie in a plane, then that entire line is going to be in the same plane. So that's from postulate 2.5. Statement. So we're saying this is true. Line M and line ST intersect at point T. Well, according to postulate 2.6, if 2 lines intersect, then their intersection is exactly 1 point. And that point, you can see, happens to be point T. Statement. Exactly one plane contains points L, Q, and S. So right there, there's my three non-collinear points. So I'm going to go back to the postulate that identifies what a plane is. So here, 2.2, through any three non-collinear points, there is exactly one plane. So that's what it says. Exactly one plane contains those 3 points. So there you have it. Again, if you are unclear, please make sure you ask your teacher. It doesn't have to end at the video. You can re-watch something if you want to, and this video will be up for the whole unit, so if you want to come back to it another time, you can. Hope your quiz went well, and we'll talk to you soon. And now you can get started on your homework from the book.